This video demonstrates how to conduct the transient structural analysis using ANSYS Workbench. The example considered here is the representative model of a gangway, or it is a bridge. The structure of this gangway is made up of steel. The elements used here are shell elements. The bridge is fixed on both the ends, and a person is walking on the bridge from one end to other end. The objective of this analysis is to capture the behavior of the structure, the deformation happening, and the von Mises stress that comes on the structure when a person will walk or run from one end to the other end of this gangway structure or a bridge. Reaction force graph will be plotted after the solution is completed. Let us begin with the tutorial. Create a new structural transient analysis file. Pick on Transient Structural. Drag it to the project schematic. Rename the file Gangway. Ensure that the engineering data is tick marked, which means default steel material is applied to this analysis file. Pick on the geometry, right click, press hold, and pick on Import Geometry. Already under the recent files, bridge.prt file is attached. Here I am using Creo Parametric interface for ANSYS Workbench. Hence, the file which is currently open in the Creo Parametric will be read by the ANSYS Design Modeler, which means you can find the bridge structure over here. This was been modeled in Creo Parametric. Right-click on the geometry, pick on Import Geometry, pick on Bridge. Observe the right tick mark, which indicates the geometry is been loaded into the geometry. Right-click, pick on Edit Geometry. This will open the Design Modeler. Make sure the ANSYS Workbench unit as millimeter. Pick on OK. The attach status is not yet generated. That's the reason why this update symbol is still highlighted. Pick on Generate. The key observation to note here is this whole structure is made up of small surfaces. At the center, the surfaces are purposely split to ensure or to facilitate for the loading. Expand the part. We can find totally 17 bodies. We can observe just below the part the symbol represent all the surfaces are combined together to form a single part called as new part, and the name of this particular assembly of the surfaces is called as a bridge. Collapse, expand the tree, we can find these many surfaces. Once the geometry is imported into the design modeler, pick on Save Project. Under the C drive, I will be saving this file in ANSYS Transient Analysis. Enter the name of the file as gangway. Enter. The project is now saved. Pick on the model. Right-click, press hold. Pick on Edit. This will open the ANSYS mechanical window. Reset the layout of the window. Pick on View, Windows. Pick on Reset Layout. Pick on the graphics. There is a question mark just beside the geometry, which indicates none of the bodies are assigned with the thickness. Select the bodies, enter the thickness as 1 millimeter. Pick on the mesh. Right-click, pick on Insert, pick on Sizing. Enter the element size as 5 millimeter. Under the geometry, ensure that the face is selected over here. Right-click, pick on Select All, which selects all the surfaces. Pick on Apply. Right-click on the mesh. Insert, pick on Mapped Face Meshing. This option will make the meshing uniform. Right-click, select All. Under the geometry, pick on Apply, which ensures the selected surfaces will be included for the mapped face meshing. The color highlighted is blue. Right-click on the mesh, pick on Generate Mesh. This will take a couple of minutes to generate the mesh. We can observe most of the elements which are present are quadrilateral elements with triangular elements in between. When we zoom it, we can find the thickness taken by the structure is 1 millimeter. The surface which got meshed is lying exactly at the center of the structure. Now it is the time to proceed with defining the analysis settings. Pick on Analysis Settings. Enter Defined by Substeps. Enter the initial substeps as 25, minimum 25, maximum 25. Apply the loads and boundary conditions. We know that the end of the gangway is fixed. Right-click on the transient, insert, pick on the fixed support. Ensure that the edge is selected in the selection filter. Pick on the geometry. Select the edges. Pick on Apply. which means this end of the bridge structure is now completely fixed. Rotate the model. Right-click, insert, pick on the fixed support again. Make sure the edge is selected under the selection filter. Pick on the edges of the other end of this gangway or bridge. Once the fixed support is defined, it is the time to define the force acting on the structure. This step is very important. Listen and understand this step very carefully. Pick on the transient, right-click, insert, pick on the force. I repeat, the main objective of this analysis is when a person is running or walking from one end to the other end of this gangway, we want to capture the behavior of the structure, also the deflection happening because of that transient loading. The meaning of the transient is short-lived or something which stays for a short span of time. Pick on the force. It should be defined by the components. Pick on the components here. We want to apply the force in the y direction, minus 20 Newton. On the geometry, that is these two faces, ensure the face is selected in the selection filter. Pick on this face and pick on this face. When we are doing the multiple selection, make sure that the control button is pressed. Pick on apply. The force is applied, that is 20 Newton, on these two faces. But when a person moves to a certain distance on this gangway, then the load has to become zero here. So the force becomes zero and it will transfer to the next surfaces. To do this, we have to define the force using the tabular data. Pick on the force, ensure the y component. Pick on the tabular data. Pick on the tabular data which is situated here. Pick on the view, windows, reset layout. Pick on the graphics over here. The tabular data is now visible. At time 0, the force on y should be 0. For 0.1 second, the force on the y should be minus 20 Newton. Similarly, the force at 0.2 second should also be minus 20. And at 0.3 second, it should go on becoming 0. 0.4, it should be 0. Similarly, 0.5, it should be 0. 0.6, it should be 0. 0.7, it should be 0. Similarly, 0.8, it should be 0. 0.9, it should be 0. Similarly, at 1, that is time 1, the force on y should be 0. Since this is a vertical loading, the force is applied in the negative y direction. at 0.1 and 0.2 seconds only. When the person moves further, at that time, the force here becomes 0 and it should go to the next 2 steps. That's the reason right-click on the force, pick on duplicate. Now pick on these faces, change these 2 faces. Pick on this face and pick on this face. Pick on apply. Here the force will change 0.2 and 0.3 only. 0.1 gets 0, minus 20. We can find here 0.2 seconds and 0.3 seconds. The 20-20 force is applied. Similarly, right-click on the force, pick on duplicate. Under the faces, pick on the next 2 faces. Pick on apply. Now, minus 20 for the 0.4 second and 0.2 second should be 0. Similarly, duplicate this force. Under the geometry, next 2 faces should be selected. Pick on apply. Similarly, here the force will transfer from 0.5 and 0.6. Similarly, duplicate the force. Under the geometry, select the next 2 faces. Pick on apply. 0.5 and 0.6 should be now loaded with minus 20 force. Duplicate the force. Under the geometry, select the next 2 faces. Pick on apply. Enter 0.7 seconds loaded by minus 20 Newton in the negative y direction. Similarly, force duplicate. Under the faces, select the next 2 faces. Pick on apply. 0.7 and 0.8 should be loaded with a minus 20 Newton force in the y direction, negative. Duplicate this force. Pick the face, the last face. Pick on apply. Minus 20 Newton force at 0.9 second. 0.7, it becomes 0. Application of the force is now completed. We can summarize. The first step, the person will be here. He moves in this path. Now, what results we want to retrieve or get or evaluate that need to be entered in the solution. Right-click, insert, pick on the deformation, pick on total, pick on the right-click, insert, pick on the stress, von Mises stress, pick on the solution, right-click, insert, pick on the probe, pick on the force reaction. The force reaction we want to evaluate on the fixed support 1 and also right-click, insert the force reaction in the probe, that is for fixed support 2. Now solve the problem. Right-click on the solution, pick on solve. The solution process will take a few minutes of time. That depends on the number of nodes and element counts we have. For this example, we can count how many number of elements and nodes are present. That can be accomplished by picking on the mesh. Under the details of the mesh, pick on the statistics. We can find here approximately 4200 nodes are present and 3400 elements are present. The solution is about to be completed. It is evaluating the results. Now we are done with the solution of this gangway structure Pick on the total deformation. We can find this is how the structure is going to deform. Pick on Animate button. This is how the structure is going to behave. It seems to have a very huge deformation happening. This is not the true scale because by default ANSYS has set the deformation scale as almost 60 times than the actual. This is just for the display purpose. We can change it to 1:1 scale. We can pick on the play animation now. This is how the real behavior of this gangway structure. Let us enlarge the scale. Pick on the graph. Pick on Animate. This behavior is enlarged. Pick on the graph, pick on Animate. Now, let us plot the graph for the reaction force which is coming on each support. Pick on the reaction force. We want to evaluate the reaction force in a particular direction, which means pick on the tabular data. In the tabular data, the reaction force is given in all directions. The force reaction in X, Y, Z and the resultant force reaction. Let us only copy the reaction force which is coming on the y-axis. Select the column of Y, right-click, press, hold, pick on Copy Cells. Let us make use of the Excel. Pick on the File, New. Create a blank document. Paste the reaction force over here. Similarly, let us paste the time. Copy and paste here. Pick on Insert. Pick on the chart. Right click, Insert or select Data. Pick on Add. Under this data need to be recorded. Pick on OK. Under the horizontal axis, pick on Edit. Under the axis label range, select these values. Pick on OK. This is how the reaction force is going to vary as the person moves from one end to other end. This reaction force plot can also be plotted for the other end fixed support. Thank you for watching this video. For more videos, please visit my channel or visit my website sites.google.com, site FEA engineering design. You can click on subscribe button just below this video so that you will be notified for my new videos in YouTube. You can contact to my email ID engineeringtutorsdesk@gmail.com, and my Skype ID is engineeringtutorsdesk. Thank you.